Hello everyone, today we are going to find this integral by first finding the derivative of tangent x squared. Getting the derivative of tangent x squared is quite manageable. All we need to do is to differentiate the trigo angle over here and change the tangent ratio to a secant squared. And remember to retain the original angle, which is x squared. Now, when we see the word hence over here, let's try to manipulate the expression in the question to be as close as you can with this derivative so that we can obtain something useful subsequently. Now, we will proceed by splitting x cubed into x squared multiplied with x secant squared dx. Now let's introduce a 2 over here with brackets to make this as close to the expression as possible, and simply introduce a half on the outside of the integral to make the expression equivalent. Now we are then ready to begin the integration process. Now notice that we don't really have a direct formula to integrate this expression, so we are going to integrate this by parts. To do so, we need to identify a u term and a dv over dx term. There is an algebraic part and a trigo part over here. So according to the order of preference for u, the algebraic expression takes preference over the trigo expression. Therefore, we are going to let u be equals to x squared, while dv over dx is equals to this expression. Immediately, we are going to differentiate u with respect to x, giving us 2x, while we are going to integrate dv over dx as well to give us an expression for v, which gives us tangent x squared. Now this comes immediately from the part which we have obtained earlier. Now to formulate the integral by parts components, you can follow this formula here, or what I like to always use is this flow. U multiplies v minus v multiplies with 2x. It's something that I use to remember things better. Now doing so, we will have this expression, and all we have to do is to simplify it. Now notice that we have also this integral over here, which looks rather complex. Now not to worry, we can think of this in two parts as well. The angle over here is related to 2x, where 2x is the derivative of the angle. So that's a relationship going on over here. Now we know that integrating tangent x gives us minus ln cosine x. So if we were to integrate tangent x squared, we need to prepare the expression in the right format for integration, which is to differentiate the angle and place it beside tangent, which in this case is 2x, and it happens to be here already without the need for us to introduce it. With this correct format in place, we will then have minus ln modulus cosine x squared. Now I've also prepared a generic formula for you if you like to visualize how it was performed. So there you have it. This is the derivative of x cubed secant squared x squared dx. It's quite a mouthful. Don't forget to put a plus c, which represents an arbitrary constant, because this is an indefinite integral. Now I do hope you have learned something from this video. If you have any comments or questions, do leave them down in the comments box below, and thank you so much for watching.